ドライビングシミュレーターでの性能評価においてタイヤモデリング手法は重要な要素です。IDIADA チャイナビークルダイナミクスデベロップメントコーディネーターゴンザロ・ラナス氏よりドライビングシミュレーターにおけるハンドリングアプリケーションのための物理タイヤモデリングについてご講演いただきます。
Konnichiwa. Good afternoon. My name is Gonzalo, and today we are going to talk about the latest advances in physical tire modeling for handling applications in Applus IDIADA. This project has been a strong collaboration between cosin scientific software and Applus IDIADA. So today we'll be discussing about the different steps of the project, from obviously the background, the methodology proposed, results discussion, and finally the conclusions and next steps. First, let me introduce Applus IDIADA. We are an engineering partner for the automotive company. We are able to provide complete solutions from engineering services, homologation, and of course our proving grounds. Nowadays we have more than 3,000 employees. We have local offices in more than 50 countries, which makes us a trusted partner for the automotive industry around the whole world. So this project especially showcases the very tight cooperation and collaboration with different areas inside IDIADA Engineering Services. Of course, we have our skid trailer for tire testing, our own tire modeling and fitting methodologies developed together with cosin, and for vehicle dynamics performance testing, we have our two proving grounds in Spain and China, and our two BA grade DIM 250 located in the same locations as the proving grounds. So, what is the current situation for tire models for handling applications? The truth is that the tire is the most critical component in chassis development, and the mainstream for tire models for handling applications nowadays, MF like MF 5.2 or 6.1, 6.2 do have some limitations. These limitations include that they are not valid for ride and comfort or high frequency applications. They are not valid for extrapolation or operating outside of the testing conditions, and they have limited consideration of temperature and pressure. Some parameters are not physically meaningful, which is especially important for tire tuning and tire model improvement. And the surface in which the tire models are tested has a major impact. So, for example, we can discuss about skid trailer versus flat track differences in the tire model performance. The focus for today, physical tire models have some advantage over traditional MF models. So this includes obviously high frequency capabilities, which enables them for ride comfort simulation. Extrapolation is less critical. The equations used are valid beyond the measurement range. They are able to adapt to changes in operating conditions such as pressure, and later we will discuss about tire temperature effect, especially for lap timing or limit handling applications. Finally, they are capable of capturing correctly smooth transitions, so this is especially interesting for active system evaluation. However, in the industry, normally FTires are not regarded as adequate for handling. That's why IDIADA and cosin have developed jointly a methodology for fitting the tire models for high accuracy in handling applications in subjective evaluation. So, how is this model generated? We start with IDIADA's skid trailer testing on the same surface that later will be evaluated for in the proving ground. Then, of course, the tire modeling and fitting. We have then the two steps, which are the correlation and evaluation of the tire performance in the proving ground and also in the driving simulator. And finally, this comparison between MF and FTire. So, regarding the testing and fitting, first of all, IDIADA has been collaborating with cosin for 9 years. We have done several projects to improve FTire model, especially focused on handling characteristics, and together we have built a very expanded knowledge on how to fit and generate these tire models. This includes testing the tires in realistic surfaces. So for example, I have just mentioned the ski trailer, strict control of the actuation in the testing, and also the operating conditions such as pressure and temperature. And finally, this proprietary fitting methodology focused on the footprint shape and also pressure distribution. After all this development, we can achieve very high level of objective correlation of the tire, but based on our experience, this is not enough. The tires need to be validated in the driving simulator subjectively. So how do we validate these tire models? Basically, the idea is to replicate exactly in every step everything in the physical and in the virtual environment. So in this case, what we did was a blind test between two different tires, one more comfort-oriented and another one more sport-oriented. And in both cases, they were tested with IDIADA's own BMW vehicle and in the proving ground, including high-speed tests, dynamic platform test, and finally the dry handling circuit for lap timing application. In the case of the virtual environment, it was exactly the same. So in this case, we were considering the digital twin generated in real time for this same BMW vehicle, the equivalent tire models for FTire and MF for the comfort and sport tire variants, and finally, the digitalized proving ground of IDIADA Spain for the same tracks. So, finally, for the results. The driver was performing a blind test in the driving simulator and the proving ground. In both cases, he identifies correctly which tire is comfort and which tire is sport-oriented, but in the case of the proving ground, the difference is slightly bigger. However, the feeling of the driver is that the FTire is performing in a realistic way in the driving simulator, very similar to the proving ground. Okay? In terms of vehicle performance, the driver can feel a progressive yaw rate feel, which helps to understand the vehicle balance. And in general, the reaction of the vehicle, so the transient response in low to medium speeds is very similar to the real vehicle. It's true that for very high speeds, there is a slightly bigger difference or gap between the FTire and the proving ground due to the rear axle delay being bigger in the virtual vehicle. Finally, when it comes to tire reactivity and sharpness, the level of simulation of FTire is very similar to the real vehicle. In addition, inflation pressure changes are perceived within a reasonable range. And finally, I would say this is a very important conclusion. Temperature variation and performance decay of the tire in limit conditions is perceived in the driving simulator. So for hypercar or sports cars performance, this is a very important difference compared to normal or traditional MF models. If we perform the same style of comparison between MF and FTire in the same conditions, we can see again that FTire has an adequate connection between the steering and the road surface, while MF has a lack of connection. In terms of limit stability, FTire behavior is more progressive, more predictable to the limit, and after the limit, still the driver is able to recover the vehicle, as in the real car. In the case of MF, basically the tire model retains very good stability up to the limit, but after the limit there is a very sudden loss of control, which is deemed unrealistic. Again, for tire compliance, subjective feeling is aligned with the real vehicle, so we can feel this damping, this connection of the tire between the steering and the road. And in the case of MF, it is more direct and has this undamped reaction. So, based on our experience and all the driving simulator testing, FTire model has a realistic handling behavior for evaluation in the driving simulator. Differences between tires are more noticeable on FTire than compared to MF due to the improvement in accuracy of FTire. And finally, another thing to take into account is that if we don't need to generate MF, this has a reduction in cost and time. So what are the next steps? FTire model develop a methodology to refine the FTire model based on subjective driver feedback, complete a detailed correlation loop with full vehicle objective testing and simulation, and finally, testing and validation of the FTire model for handling in low adherence conditions such as snow or wet surfaces. So that was all for me. Thank you very much for your attention today, and feel free to get in touch with me today or through email. Thank you very much.